So now we're going to look at moving horizontally, which means along the x-axis. So doing a horizontal shift, and then we'll have another video for horizontal stretch or compression. Now with the horizontal, since we're changing x, what we'll notice is our operations will be inside of our function now, which means we have to simplify inside of our function first before we can see our new output value. And with this, because we're doing that work before we evaluate the function, things end up working kind of opposite of how we expect it to. So let's look at some examples here, and I'll give you my tips for how to think of these. So what we're going to do is look at this f of x plus 3. So what that means is I need to think to the side first, before finding my y value, of taking my original x value plus 3. So my x here is -6, so what I need to do is take -6 plus 3. So really I'm looking at f of -3 here. Well, f of -3 is +7. So that's where I'm finding this x value first and then plugging into the function. If x is -3, so really I'm looking at -3 plus 3, which is 0, and f of 0 is equal to 10. If I'm using x equals 0, I'm doing 0 plus 3, which is 3, so really I'm looking at f of 3 right here, which is 13. So notice these values that I'm grabbing, these values are coming from 3 spaces to the right, or 3 x units to the right. But where we're getting this information to look to the right, what we're grabbing, that y value, is actually moving to the left. So where x is moving to the right 3, our y values are moving to the left 3. You know, it's strange. It's hard to wrap the mind around. But what we're going to end up with is this table of outputs are all going to move to the left 3 spaces along that x-axis. So let's keep looking at these. This is f of 3 plus 3, which is f of 6. So really we're looking at an output of 11. F of 9 plus 3, which is 12, which is undefined. F of, I jumped over. 6 plus 3 is 9, so this would be 9. F of 9 plus 3 is 12, this would be undefined. And f of 12 plus 3 is 15, undefined. F of 15 plus 3, 18, which isn't on the table, so that's also undefined. Okay, so how we're grabbing these values, like I was saying, is coming from an x value 3 spaces to the right. So that's where the plus 3 kind of works with how we saw the vertical shift. However, in terms of graphing, we're focused on outputs and how the outputs move. So by looking at x 3 spaces to the right, we're grabbing y values that are 3 spaces to the left. We're moving them over to the left. So what that means, if we look at f of -6, we're graphing that +7. So what we did is we took this original value of -3, -7, and it moved over there because we wanted to grab the value from this 3rd space to the right on the x-axis, which moved it over there. Okay, and then we'll have 10 and 13 and 11 and 9. And that's all of them. Okay, so with this +3 that we're seeing inside of the function, what it causes is a shift to the left 3 units. So that's where I was saying these are going to behave opposite of what we're used to, because typically we think of positive as a movement to the right, but with this layering that's occurring of how we're evaluating the x value, it's actually going to work opposite of our instinct. So if we see +3, that means we're moving to the left. Similarly, when we look at this example where we have subtraction, we're going to see movement to the right. So what we could do is predict we're going to shift to the right 6 units. But let's go ahead and actually find those. So f of, and our x value is -6, and then subtract 6, so we're at -12, but that's, we don't know what that is. F of -3 minus 6 is -9. That we also don't know what that is. F of 0 minus 6, so f of -6. It's on our table, but it's undefined. F of 3 minus 6, so -3. So there's our 7. F of 6 minus 6, so 0, which is 10. And f of 9 minus 6, which is 3. And then f of 3 is 13. F of 12 minus 6, which is 6. And f of 6 is 11. And then f of 15 minus 6, which is 9. And f of 9 is 9. So with this case, what we're doing, like let's look at x equals 6. What we're doing is x is moving to the left 6 spots. So the y value that we're grabbing is coming from 6 spots to the left, and we're moving it to the right 6 spots. So what this will look like is, let's see, our function starts at +3 and 7, and then that, and that, and that, and that. Here's our new function. And what we can see here is where we have an original coordinate. We moved it to the right 6 units. Where with the blue function, we moved it to the left 3 units. Okay, so the punchline is going to be, with the input of your function, if you see addition of a number, it's going to be moving to the left. If you see subtraction with a number, it's going to be moving to the right. So for our general form, this horizontal shift is coming from adding or subtracting a number with x inside of the function. If we're adding or subtracting on the outside of our function, that's our vertical shift, but inside. And then if h is positive, which means inside of your function you're seeing x plus, in fact I won't even say h here for this general form, but x plus some number. So if you see addition in there, you're moving to the left. If h is negative, which means you're seeing x minus the number, then that's telling you to shift to the right. So this vertical shift and horizontal shift, we've already looked at a little bit with our vertex form of a quadratic function. So if our original function is x squared, what we're doing here is this is kind of like taking, it's not even kind of like, this is exactly like taking, let me call this f of x. Our original function is x squared. So what we're doing here is, for the input of the function, we're adding 4 to the input. So this is like f of x plus 4. And then we're subtracting 3 outside. And then it just happens to be that my function is x squared. So if we think in terms of a transformation, my original function is the quadratic that goes through the origin. But what this would tell me to do, so with the plus 4, that tells me to go left 4, and the minus 3 tells me to go down 3. So if I move the origin following that map there, and this is something we'll practice more, I just wanted to make this connection while it's kind of fresh. So left 4, if I'm moving the origin, I go left 4, down 3. So my vertex would end up down here at the coordinate -4, -3. which is exactly what we learned with this vertex form. Remember, x changes sign, y stays the same. And then we'd have our quadratic. So we've already seen these shifts come through with this vertex form. We just hadn't learned graph transformations yet to make that connection. We'll talk about that some more in our future videos. All right, so here's our original function, and what we're going to do is look at these transformations. I'm going to pause the video real quick and set up some scales so you don't have to watch me set them up. Okay, and like magic, there are new scales, and I even drew on our original function there. I just didn't want to have to watch me go through all those little tick marks and things like that. So something I thought about and why I needed to stretch out the scale so that 2 units is equal to the distance of 1 here is because looking at this original graph, what we can see is these really short distances of 1s, and then we're even kind of looking at these important values that are happening at a half there. So when we're doing vertical shifts, that scale is going to stay pretty much the same since we're not stretching or compressing anything. When we start stretching and compressing, then we can talk about when do we want to have smaller scales and larger scales for our axes. All right, this first example here. So what I'll notice is that the subtraction with 3 is happening inside the function, so that's where I know it's going to be moving left-right. And then it's negative, so it's going to the right. And you'll hear me pause with these because I do think of like, what do I expect it to happen? Then I just need to do the reverse of what I think it should be. So this is moving to the right 3 units. So where I have my original function, I'm going to go 1, 2, 3. And I should just learn my directions a little bit because I was to the left. Okay. 1, 2, 3. There we go. And go 1, 2, 3, 3, 3, 3. All right. Left, right helps. And then we'll just connect these, the curve that it is. All right. Then down here, so I have +1, and that will mean we're moving to the left, and we're moving to the left 1 unit. So to the left 1, left 1, 1, 1. So we'll have our curve like that. And here, so with the shift, order doesn't matter in terms of horizontal or vertical shift, so we can do either way. When we start doing stretches and compressions in here, we want to do stretches and compressions first, and then we'll shift up, down, left, right. So let's do the inside first. So my first step, I'm going to go, let's see, +1, so that'll be left 1. And then we'll do the outside, so the subtraction of 2 on the outside is a vertical shift. And it's negative, so we'll be moving down 2. So first thing I'll do is I'll just move these points left 1. So I won't make that solid yet. And then down 2, so I'll go down 2. That's down 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And then since I have some pieces in there, I'm just going to use a bigger pen to show this is where our function ends up. So with those coordinates there, we end up, so we went left 1, down 2. And maybe you can figure that out. Like, it's all about tracing the points, so you don't need to draw this middle step here. Maybe you just take one of the points and go left 1, down 2, and you graph your point. And left 1, down 2, and you graph your point. So you don't need to do these middle steps. It's just as we layer these on, it might be helpful. But if you find it's easier to skip some of the middle steps, you can absolutely do that.